Hey guys, welcome back to day 45. We're going to do some a gas stoichiometry problem and a bunch of problems today in this video. So gas stoichiometry, this is where you have two gases mixing. There's a limiting reactant. And there's usually a total pressure. This is a top 5. So this is the last of the top 5 problems that we like. So let's dive into it. I have 3 liters of 3 atmospheres of N2O, and I have 2 liters of 5 atmospheres of O2. And there's a glass tube here, glass bulb screen by a tap, which is closed. Negligible volume in that tap. So it just tells you what you have in the first bulb, second bulb, constant temperature. So we maintain a constant temperature throughout. So that means temperature is not changing. We don't know what it is, but it's not changing. The tap's open, the gases are allowed to mix, and the reactor produced nitrogen dioxide according to the equation written below. Assume the reaction goes as far as possible to completion. And there's 3 questions. What's the partial pressure of nitrogen dioxide in the apparatus at the end? So right here, I want to know how much NO2 we have. What's the partial pressure of the non-limiting reactant? And then what's the total pressure? So at the end, I have the pressure of the total pressure of the apparatus will equal the pressure of whatever N2O is, the pressure of what O2 is, and the pressure of NO2. Now, one of these 3 will be 0 because the limiting reactant. And we'll go from there. So first, what happens? Well, we have a before the reaction, but once we open the tap. So once we open this tap, what happens? The gases mix. N2O can come through and go into the O2, and O2 can come into the N2O. So we have a volume change. There's a volume change. Ooh, my writing today. Try that again for you guys. The volume change. But there's no temperature change. So the temperature doesn't change. The moles aren't changing yet. The volume changes. The pressure needs to change. So for N2O, I have P1V1 equals P2V2 because T is constant. 3.0 atmospheres, 3 liters equals the new pressure times, it looks like, what's the new volume? 3 and 2 is 5. Is that right? 5. So that would be 9/5. So the pressure of N2O becomes 9/5 atmospheres. Then we got O2 here. So let's do O2. P1V1 equals P2V2. I have 5.0 atmospheres, 2.0 liters, P2 times 5.0 liters. So that means my pressure of O2 looks like it's 10/5, or 2 atmospheres. Okay, so I have 9/5 and 10/5. Perfect. I'm going to come back down here. I'm going to rewrite my balanced chemical equation. My balanced chemical equation is 2N2O plus 3O2 going to 4NO2. All gases. And I have 9/5 atmosphere to start with, and 10/5 atmosphere to start with. I'm just keeping them that way to compare. All right, limiting reactant. So who is limiting reactant? Well, 9/5 divided 2 would be 4.5/5, and 10/5 divided 3 is 10 divided by 3 is what, 3 1/3? 3.33 fifths. That means oxygen is going to be my limiting reactant. It's smaller. I'll start all my calculations with 10 fifths or 2 atmospheres. So you don't have to use fractions. I just do because it's calculator free. So we start with 10 fifths atmosphere of O2. I'm going to write this way. And we're going to multiply. We know it's 3 atmospheres of O2 to 4 atmospheres of NO2. Why? How can I do that? Well, if we go PV equals nRT, let's talk about what changes, what doesn't. R, of course, does not change today. All right, the gas constant. The temperature is constant. Once I open the volume, right, up to 5 liters, so once we come back up here, once this tap here is opened and everything is one now apparatus, that volume's not changing. In fact, it's glass, right? It says it's glass. Yeah, 2 glass bulbs. So we're not going to expand and contract hardly at all. If they do expand, they break. So the volume's fixed. Now, I don't know what T is, so I can't plug in PV equals nRT to get the number of moles. But I do know that it doesn't change, R doesn't change, and V doesn't change. So that means the pressure is proportional to N. So whatever happens to N happens to P, and whatever happens to P happens to N. So if P doubles, N doubles. If P halves, N halves. So we can use pressure in place of moles because the multiplication change that happens with pressure is the same that happens with moles. So that's why we can do that. And this becomes 40/15 atmospheres of NO2 produced. Or we can make that, what, divided by 8/3? Yeah. Or we can do, what is that, 2.7? Any of those three work for number 1. Number 2. What's the partial pressure of the excess non-limiting reactant at the end? So how much N2O is left? Well, we start with 10 fifths atmospheres of O2. And we know there are 3 atmospheres of O2 for every 2 atmospheres of N2O. So that means that equals 20/15 atmospheres of N2O used or consumed. That's how much reacted. Okay. Now, 20/15 is also what? If you divide those by 5, that's 4/3. Again, it doesn't matter to me how you do the math. So you can get 1.3 atmospheres as well. I don't care. So you start with N2O at 9 fifths. Or, if I triple everything, 27/15 atmospheres. And I use 20/15. So that means I have 7/15 atmospheres of N2O remains. So my total pressure will equal my 3 potential gases. I only have 2 left. N2O, O2, and NO2. Well, N2O is 47/15 atmospheres. O2 is 0, and NO2, nitrogen dioxide, is 40/15 atmospheres. Ooh. So if we add that up, my total pressure looks like it's 47/15 atmospheres, or we can do 3.1 or 3.13 atmospheres will work. That's all this is. So I used the fractions because it was easy for me to add. But you do what you want to do with that. So what did we do again to recap? We had to figure out the new pressure once we open the tap because the gas is mixed, so the pressures change. All right, then we figured out their new pressure. After we figured out the new pressures, we found the limiting reactant. Then we start with the limiting reactant. We can use atmospheres in place of moles because pressure is proportional to moles. And it's just like every other stoichiometry problem. And at the end, we just had to add up the partial pressures to get the total pressure. That's gas stoichiometry. So you will have one of these on your final exam.